Properties of parallelograms, section 6.2. So yesterday we talked about polygons. Today we're going to talk about a specific polygon called a parallelogram. As you look at the word parallelogram, what root word stands out? Parallel. Does anybody know some facts about parallelograms before we get started? What's something you know about parallelograms? They are what, Trevor? What's parallel? Yeah, the opposite sides are parallel. Nice job. What's something else you know? Camden, you had your hand up. Did you know anything else? Or is that what you were going to say?
Like the angles.
What about the angles?
Aren't the opposite, like the diagonal angles congruent?
Nice job. Opposite angles are congruent. That is correct. Good work, sir. Anybody else? Anything else about parallelograms before we get started?
They're squares sometimes.
The consecutive angles are supplementary. Nice job. Okay. Anything else? Anything else? Yes, sir.
They're squares sometimes.
Parallelogram. A square is a specific parallelogram. Nice job. I agree with that. Yes, sir.
The diagonals bisect each other.
Nice job. Yeah. All of these are properties of parallelograms. Here are some more properties of parallelograms. So a parallelogram is a quadrilateral with two pairs of parallel sides. So opposite sides are parallel. All parallelograms, such as FGHJ, have the following properties. Opposite sides are congruent. That's something nobody said, I don't think. Opposite sides are congruent. That is true of every parallelogram. They're not only parallel, but the opposite sides are congruent. Opposite angles are congruent. Camden said that one. That is true. The opposite angles are congruent. Consecutive angles are supplementary. What's it mean to be supplementary, Ryan? That means they add up to 180. Yeah, supplementary angles. Does anybody know why that is true? If you think about that, what theorem or postulate says that? If you think about that, I have two parallel lines. What theorem says that those are 180?
Well, if you bisect them in half, it's two triangles.
Not quite what we're thinking. Yes, sir?
The same side.
Yeah. If you think about it, these are both, for example, right there and there, those would be same side interior angles. Same side interior angles are supplementary. They do add up to 180. That's why that is true. They are same side interior angles. And then the last thing we talked about, the diagonals bisect each other. What's it mean to bisect, Bryce? So it's in the middle. It cuts it in half. So the two are congruent. Nice job, sir. So as we look here, number 1, I want to find the distance for AB. So I want to find this distance right here from AB. If I look at that distance AB, what would the distance be? Keegan, what are you thinking, sir?
Whatever the number on the right is.
I agree with that.
Yes.
The number on the right is 10, so what's AB?
10.
It is 10 centimeters. Nice job, sir. That's weird. I don't know. Parallelograms, though. I don't know. That's weird. Number 2. It says the measure of angle D. What is the measure of angle D here going to be, Anna? How do you figure that out, Anna? And those two have to be what? Supplementary. They have to add up to 180. Nice job. Those are all properties of parallelograms. Using that information, try these 6 problems on your own. All right, let's start going through some of these. First one I want to do is I want to find ML. Mots, what is ML going to be, sir?
12.
It is 12. Nice job. What about LP? What is LP going to be, Hannah? It is 10. Nice job. What about number 5? LPM. I want to find angle LPM right here. Oh, man, that's a tough one. I don't know about that one. What are you thinking, Ryan? It is 62 degrees. How do you know it is 62 degrees? What type of angles do we have here? Those are alternate interior angles. Nice job, sir. Recognize that. Parallel lines, alternate interior angles. We're still coming up with all those things we've learned back in chapter 3. What about number 6, LN? What would the distance for LN be? Mr. Goldap.
Hold up. LN 18.
LN is 18. How do you know that, sir?
Because L cubed is 9. L cubed is half.
Good work, sir. That's great. Couldn't have explained it better myself. Number 7, angle MLN. I want angle MLN. What do you say right there, Jersey? That is 32 degrees. Why is that 32 degrees? What postulate or theorem, Jersey? Alternate interior angles. And last but not least, QN. What would QN be, Tyler?
9.
QN is 9. Nice job. So good work. So parallelograms, find some of the basic parts there. Pretty straightforward. Well, what happens if I don't have the exact angles, but I need to find them? For example, what happens if I give some angle measures like this? What do I... Say it again. Gilbert. Yeah. I add those and set them equal to 180. Nice job, ma'am. So I would set those two angles equal to 180. And solve for x. And then don't always forget, but make sure you plug it back in and find for the angle that's indicated there. Okay, so again, same side interior angles add up equal to 180. So number 9 here, let's think about this. CDEF is a parallelogram. I want to find each measure. What do I know about segments CD and EF? What is something I know there, Tom? What do I know about those two segments? They're parallel. What else do I know? They're also congruent. So what do I have to do to solve for W for those two segments? I set them equal to each other. So 4W plus 8 equals 5W plus 1. And I solve for W from there. When I solve for W, what do I get, Jack?
7.
W equals 7. Is that my answer, Jack? No, because what's it want me to actually find?
Gotta plug it back in.
And I plug it back in. So CD equals what, Jack?
36.
And EF equals what then, Jack?
Oh, 36.
36 as well. Good work, sir. Next part. It says angle F and angle E. Well, what do I know about these two angles, Anna? They equal 180. So to solve for them, what do I have to do? Yep, so 9z minus 12 plus 3z equals 180. And now I solve for z. So that gives me 12z equals 192. And z comes out to equaling... What does z come out to equal, Caitlin? It is 16. Is that my answer, Caitlin? No, because what do I have to do then? Plug it back in. So I want to find F first. So F would be 3 times 16. 3 times 16 would give me what angle measure, Drew? 48 degrees. Good work, sir. And then I could plug it back in to find E. Or I can maybe just subtract 180 minus 48, and I can get E as well. Either way, what's angle E come out to be? What'd you say? 132 degrees. Nice job, sir.
I was writing it down.
Good work. All right, some key parts there of parallelograms. Try these two on your own. What do I know about these two angles? So if I look here at angles S and angle N, what do I know about those two angles, Jessica? They're not the same, but they add up equal to what? 180. So I have 10N plus 8N equals 180. And I solve for N then. What does N come out to be, Drew?
10.
N equals 10. Then you plug both those back in, and what's angle S going to be, Ryan? 100 degrees. Nice job, sir. And angle R comes out to be what then, KZ? 80 degrees. Nice job. Last thing we're going to talk about here is we're going to talk about properties of parallelograms in the coordinate plane. So for example, I have 3 vertices, R, S, and T, and I want to find the coordinates of V. A couple things here. Opposite sides must be parallel. We talked about that for parallelograms. So that means the rise and the run must be the same. Okay, and what's rise over run basically? That is the slope. So rise over run is my slope. Alright, so what happens here is I can do this 2 different ways. I can say, well, the rise and the run from S to R is 4, 4, so they do 4, 4. Or I could go from my other point. I could say S to T is 1, 4, so R to V is 1, 4 as well. Either way, I get my 4th point, and now I make my parallelogram right there. Okay? So let's try the next one here. This goes step by step, helping us out here. Number 15 says to plot the vertices G, H, and J on the coordinate plane. G is at 0, 0, H is at 2, 3, and J is at 6, 1. Okay, now, some students in the first class they tried making triangles. What are we working with? Parallelograms. Don't connect all 3 of those dots. We're dealing with parallelograms. Okay, so I'm going to connect congruent segments here. So, for instance, that dot goes there. That one goes there. I have something that looks like this right now. Okay. I want to find the rise, the difference in the y-coordinates from G to H. So here's G, here's H. What is the rise going to be from G to H? If I were to find the slope from G to H, what's my rise there, Noah? My rise is 3. What is my run, Noah? 2. So my slope is 3 over 2. Rise over run. So from my other coordinate, from this coordinate right here, what am I going to do with the slope, would you suppose, Max? So what would I do then? I would go up how many?
3.
Over how many?
2.
My new coordinate is right there. And now I can finish out my parallelogram. There is the parallelogram right there. And how do we do that? We found that all with slope conjectures. Okay? And then another way is, well, I can check it. I can check the opposite slopes. For example, what's the slope of that yellow line right there? Anybody, what's the slope of that yellow line right there? 1, 6. What's the slope of the top line then? 1, 6. They are the same. They would always be the same. Okay, now the next one here. I realize I kind of gave you a small grid. I'm sorry. I didn't realize that. It all works if you go like this. If you make this your axis right here, and make this your point 0, 0. Okay, make that your point 0, 0, and then plot your coordinates. Everything fits on the grid then. So make that one 0, 0, and plot everything from there. Try this one on your own. Ooh. Yeah. So I plot my coordinates here, 0, 6. I have 5, 8. And I have 5, 5. So you should have 2 segments that look something like that. Now, we all know what type of shape are we making here. We're making a parallelogram. So would a coordinate like this one right there make sense? No, that one wouldn't make sense. Would a coordinate like this one right here make sense? No. Okay. So use some of those, thought processes there to think about where's the kind of a realistic part. So as I look at that here, now technically here we know parallelograms are 2 things. They're parallel, but opposite sides are also what?
Parallel.
Opposite sides are parallel. They're also congruent. What's my distance right there?
3.
So what are you supposed to have to do on the other side?
3. That's what I did.
Hey, look. There's my 4th point. And now I get my parallelogram. Nice job. feeling pretty good about this? Great. We will skip the next one then, and we will just go straight to that assignment because you guys are doing so well.